In this video, I'm going to describe my first trial of automatic tram stops using DCC and the Lenz ABC braking system. Automatic operation on model tramways is not something new. However, on DC layouts, this usually involves using live overhead. While it's reliable, trams do tend to stop and start rather abruptly. Also, on DCC layouts, particularly good electrical continuity is required so that signals from the controller can get to the decoders without disruption. Live overhead in small scales, such as OO or HO, would probably not work very well in this respect. So, how exactly does this all work? The first step is to completely isolate one rail for a length slightly longer than one tram. This rail then needs to be fed through the Lenz Brake Module 1. This is to enable a feature called ABC braking to operate. Once a decoder has entered a section which is being fed through a Brake Module 1, it can detect this, and if the correct CVs are enabled, this will then bring the tram to a stop. By bypassing the board with an ordinary on-off switch, which is connected to the standard track feed, it's possible to restart the tram. As soon as the decoder senses the feed has returned to normal, the tram will then resume its original speed. We can now observe this in operation. The tram enters the section with the track being fed directly through the brake module. Once the tram has come to a stop, we can then flick the switch. The tram then detects it's receiving its power directly from the controller again and will set off, eventually resuming its original speed. As we are not cutting the power to the track to stop the tram, the lights remain on and can even be switched on and off using the controller if you so wish. So we now have manual control of our tram stop, but how do we make this automatic? Well, we need a couple more things. The first is a simple reed switch, like the one pictured here. The second is a latching relay circuit. The reed switch needs to be placed carefully between the rails, as this is what is going to trigger our automatic tram stop. This will be triggered by small neo-magnets. For this test, I simply put them on the bottom of the trams using blue tack. However, it will be possible to glue these in place and paint them to disguise them if you so wished. Although in theory you could use the reed switch to trigger the tram stop directly, it would only energise the tram stop for a split second. Therefore, I decided to use a latching relay circuit. I picked this one up on eBay for around £6. It's got 7 screw terminals and 1 micro USB socket. The micro USB socket is used to power the board, although you can use the 2 terminals to the left of the 7-segment display to power them through a normal 12V DC supply. However, when I tried this using a spare railway controller, the board wouldn't function, which suggests that it needs a very pure DC supply in order to operate. The other 2 terminals on the left-hand side of the board are for the trigger switch, in this case the reed switch. The relay is to the right of the board, and the 3 terminals to its right are the output terminals. The middle terminal is the ground or common, the terminal above is the normally open, and the terminal below is the normally closed. This image shows how I have the board set up. At the top, you can see I'm using a micro USB charger to provide the power. The reed switch is connected to the 2 lower terminals on the left-hand side of the board. The feed from the controller goes into the common, and the feed to the stop section goes to the normally open. This means the switch is normally open, so only when the relay is activated is power supplied to that section of track. When the relay is activated by the reed switch, the red light comes on. The timer then counts down, in this case 4 seconds, until a relay is deactivated. It then remains in that state until it's triggered again. I'm not going to go into details about how I programmed the board, but it was very easy and only took me a few minutes. Here we can see the tram approaching the reed switch. The relay is activated and the timer counts down. It's important to ensure that the time delay gives the departing tram enough time to start, but isn't still switched on by the time the arriving tram gets to the stop. You should also be aware that you will need to adjust the acceleration and deceleration CVs on your tram's decoders to ensure that they come to a stop within the tram stop itself. These are allocated to CVs 3 and 4 on all decoders. It's also important to remember that not all DCC chips have ABC braking capability. All chips made by Lenz presently do, as do most decoders made by Zemo. The most basic models by each manufacturer can be obtained for around £20 as of January 2021. A quick search online will provide you with much more concise information on Lenz ABC braking. This is only intended to be an overview. I hope you found this video interesting and informative.